trends in physical and chemical properties of hydrogen halide. That is how the hydrogen halides can be prepared. Here hydrogen fluoride, hydrogen chloride, hydrogen bromide and hydrogen iodide. How is hydrogen chloride prepared? By the direct combination of hydrogen combines with the chlorine to form hydrogen chloride. How is hydrogen fluoride prepared? It is the reaction between hydrogen combines with the fluorine is a violent reaction. The reaction between hydrogen and bromine and hydrogen and iodine are reversible reaction, but do not produce pure forms. Next, we can discuss about the displacement reaction. The 10th grade we maybe learn about displacement reaction. It is one of the chemical reaction in which a more reactive element displaces less reactive element to form its compound, that we are saying displacement reaction. Concentrated sulfuric acid displaces hydrogen chloride from ionic chloride. At a higher temperature, the hydrogen sulfate formed react with further ionic chlorides. Here, what is the use of displacement reaction? The displacement reaction can be used for the preparation of hydrogen fluorides from ionic fluorides. Next, about the hydrogen bromide and hydrogen iodide are oxidized by concentrated sulfuric acid, and it cannot be prepared by this method. What is the reason means? Because it is one of the displacement reaction. Am I right? Next, about the hydrolysis of phosphorus trihalide. How we are going? Hydrolysis, phosphorus trihalide undergoes hydrolysis. We know that phosphorus trichloride undergoes hydrolysis. We get phosphorus acid and also hydrogen halides. That is, hydrogen combines with the halogen to form hydrogen halide. Okay. Phosphorus acid. What is the formula? H3PO3. Am I right? So, how can you balance the equation here? The product side 3 oxygen having, so make it 3 water molecules. So, px3 plus 3H2O gives H3PO3 plus 3HX. Now the equation is balanced. Next, about how can you prepare hydrogen bromide? It is obtained by the adding of bromine drop-wise to the paste of red phosphorus. Okay. And water. Here hydrogen iodide is conveniently produced by adding water drop-wise to a mixture of red phosphorus and iodine. First, we can prepare about the phosphorus trihalide. How can you prepare the phosphorus trihalide means? We are taking a red phosphorus, that is P, on reacts with halogen. We are taking X2 halogen gives PX3 phosphorus trihalide. We have to balance the equation. Reactant side X2, product side X3. So make it the product side 2. So 2px3. So come to the reactant side 2 phosphorus. Phosphorus balanced. Next, about the halogens, we are giving X3x2. Now the equation is balanced. Next, the px3, one of the phosphorus trihalides, reacts with, we are adding water. We get phosphorus acid H3PO3. And also hydrogen combines with the X to form HX. So how much oxygen in the product side? 3 oxygen, so make it 3 water molecules in the reactant side. So hydrogen also make it 6 having, so make it the product side 3HX. Now the equation is balanced. What is meant by X? X may be bromine, otherwise iodine. Next, from covalent hydrides, how will you prepare hydrogen sulfide? Otherwise we can be say hydrogen halide. Okay. Here, hydrogen sulfide, the formula is H2S. On reacts with X2, maybe one of the halogens. Am I right? X2 we get. Hydrogen combines with the halogens to form HX. And we get sulfur. Okay, plus sulfur. How can you balance the equation? X2, the reactant side X2, so make it the product side X. Am I right? Sorry, 2HX. So how much hydrogen? 2H. Okay, now it is balanced. Next about hydrogen chloride is obtained by as a byproduct of reaction between hydrocarbons of halogens, hydrocarbons of one of the halogens, hydrocarbons of halogen. Hydrogen chloride is obtained as the byproduct of the reaction between hydrocarbons of halogen. For example, which one is a hydrocarbon? I am taking one of the hydrocarbon, benzene. What is the formula? C6H6. Am I right? This one reacts with one of the halogen. I am taking Cl2, halogen. One of the hydrogen from benzene on reacts with Cl to form HCl. So what is the remaining one? This chlorine will be attached to the benzene ring. So we get the product. First you have to write HCl plus C6H5Cl, chlorobenzene. This is one of the reaction. Next we can discuss about some of the general properties about the hydrogen fluoride, hydrogen chloride, hydrogen bromide, and hydrogen iodide. Here two factors we are taking. One is about that bond dissociation enthalpy and percentage of ionic character. Two factors we are taking. What is about the bond dissociation enthalpy of hydrogen halide? And what is about the percentage character? From hydrogen halide, that means fluorine to iodine. The bond dissociation enthalpy is decreases. Okay. And also ionic character also decreases from fluorine to iodine, that is fluorine, chlorine, bromine, iodine. This is one of the theoretical value. The hydrogen that we can be say about that decrease the bond dissociation enthalpy, the thermal stability of hydrogen halide decreases from fluoride to iodide. That is an important point. Okay, decreases from fluoride to iodide. Okay. Next, the bond dissociation enthalpy can be written as for hydrogen fluoride. HF is plus 562 for hydrogen fluoride. There's a bond dissociation enthalpy. Okay, this measured in kilojoules mole inverse. Don't forget that the bond dissociation enthalpy is measured in kilojoules mole inverse. And also the percentage of ionic character about the hydrogen fluoride is 43. Next, about the HCl, the bond dissociation enthalpy plus 400 31. What is the percentage of ionic character is 17. This is a theoretical value. Okay, theoretical value. Next, HBr, the bond dissociation enthalpy is plus 366. Percentage ionic character is 13. Bond dissociation enthalpy of hydrogen iodide is plus 299. Percentage of ionic character is 7. So don't forget that the bond dissociation enthalpy is decreases from fluoride to iodide. This is one of the one-word question. Try to understand that one. Next, hydrogen iodide decomposes into hydrogen and fluorine. Am I right? Here the temperature is about 400 degrees Celsius. 400 degrees Celsius. Next, about what are some of the physical properties. At the room temperature, hydrogen halides are gases, but hydrogen fluoride can be readily liquefied. This is when at the room temperature. Hydrogen halides are gases, but hydrogen fluoride can be readily liquefied. The gases are colorless, but with the moist air, it gives a white fumes. Okay. In hydrogen fluoride, they are having a strong hydrogen bond. Hydrogen fluoride, it have the strong hydrogen bond. It has the high melting and boiling point. This effect is absent in the other hydrogen halide. Hydrogen fluoride having one of the strong hydrogen bond. What is about the hydrogen bond? Hydrogen bond. Hydrogen combines with one of the highly electronegative atom, that is fluorine. Fluorine is one of the small size, am I right? While we are comparing chlorine, bromine, iodine. Anyhow, the fluorine is easily react with the hydrogen due to the intermolecular hydrogen bonding. Intermolecular hydrogen bonding. So you have a strong hydrogen bond, am I right? Just like water also having a strong hydrogen bond, am I right? Oxygen bond with hydrogen, one of the strong hydrogen bond. This is about the hydrogen bonding. Here, it has a high melting and boiling point. Due to this hydrogen fluoride, it is easily make the bond with high strong, okay? But this is absence, this effect is absence in about HCl, HBr and H iodide, am I right? Next, about the acidic property. What is about the acidic property? Hydrogen halide, I am taken as HX. On reacts with water molecule, we get H3O plus X minus. H3O plus hydronium ion, am I right? Hydronium ion. Here, this we are saying the hydrogen halides are as an acidic and also known as hydrohalic acid. There is a hydrochloric, hydrobromic, hydroiodic. These are all some examples. These are all acids, that is a hydrochloric acid, hydrobromic acid, hydroiodic acid, are almost completely ionized. Therefore, they are strong acid. That is a HCl, HBr, HI. These are all strong acid. But HF is a weak acid. Weak acid. HF, hydrogen fluoride, is one of the weak acid. That is 0.1 mm solution is only 10% ionized. But in 5 15 solution, HF is a stronger acid due to the equilibrium, that is undergoes both the forward and backward reaction. For example, hydrogen fluoride reacts with the water, we get H3O plus plus F minus. HF plus F minus gives HF2 minus. At high concentration, the equilibrium involves the removal of fluoride ion. It affects the dissociation of hydrogen fluoride and increases and the hydrogen ions concentration. Here we are having some of the salt, stable salt, due to the reaction between hydrogen with the fluorine, and some of the metals, we get stable salt, one of the stabilized form of salt. That is sodium hydrogen fluoride, NaHF2, potassium, like that, KHF2, and ammonium, NH4HF2. Sodium hydrogen fluoride, potassium hydrogen fluoride, and ammonium hydrogen fluoride. These are all some stable compounds due to the reaction, that's a dissociation of hydrogen fluoride with water. Am I right? Next, hydrohalic acid also show the acidic property. It also forms salt with acid bases, and also it reacts with metal to form hydrogen gas. Moist hydrofluoric acids rapidly reacts with the silica and glass. One of the very important equation is there, my dear children, one of the very important equation. One of the silica combines with the hydrogen fluoride. The silica reacts with the fluorine to form SiF4, silica tetrafluoride. And also we get water molecules. How can we balance the equation? SiO2 plus HF gives SiF4 plus H2O. The products are having 4 fluorine, so the reactant side make it 4HF. So how much hydrogen is there on the reactant side? 4, so make it 2 on the product side, 2H2O. Now the equation is balanced. Next, again we are taking sodium silicate formula, Na2SiO3 reacts with hydrogen fluoride. We get Na2SiF6 plus we get water molecule. Here how much fluorine is there? Product side 6 fluorine, so make it the reaction side also 6HF. How much oxygen is there? The reactant side 3, so make it 3 water molecules. Now the equation is balanced. Next, about the oxidation reaction. Hydrogen iodide is easily oxidized to iodine. Hence it acts as a reducing agent. That is, HI gives equilibrium, one of the equilibrium reaction we get 2H plus plus I2 plus. Here 2H plus means loss of 2 electron. So make it 2 electron minus loss of 2 electron. Reactant side make it 2 also, 2HI. The acidic solution of iodines is readily oxidized. And one of the very important one-word question. During this reaction, the liberation of iodine, which gives a blue-black coloration with the starch. What is the color here? Blue-black. Am I right? Blue-black coloration with starch. That is, iodine gives a blue-black coloration with the starch. Don't forget that is one of the very important one word. Hydrogen bromide is more difficult to oxidize as we are comparing hydrogen iodide. Here hydrogen bromide slowly reduced sulfuric acid to SO2, sulfuric acid. What is the formula of sulfuric acid? Previously we learned that sulfuric acid raised to SO4. It is slowly reduced into SO2. Slowly reduced into SO2. Am I right? How can you write the equation? HBr reacts with sulfuric acid. That is H2SO4 gives. Hydrogen bromide is converted to Br2 plus SO2. That is sulfuric acid is reduced into SO2. And also we get water molecules. Br2. How much Br is there? 2 Br. So make it the reactant side. 2 HBr. And about that water molecules here having reactant side 2 hydrogen. 2 plus 2, 4. So make it 2 and the product side 2H2O. Equation is balanced. Next. Hydrogen iodide is reduced sulfuric acid into hydrogen sulfide. Sulfuric acid into hydrogen sulfide. But it cannot be converted into sulfuric acid into SO2. Only one possible, it can be hydrogen iodide can be rapidly reduced by sulfuric acid into hydrogen sulfide, not sulfur dioxide, hydrogen sulfide. The equation is very, very important, okay? Equation. How can you write the equation? First we have to take hydrogen fluoride. Hydrogen fluoride. That is HF and reacts with the sulfuric acid. We get water molecules. That is before that, which product first we get? How to write hydrogen sulfide, H2S, plus water molecules, H2O, plus hydrogen sulfide, that is iodine. Am I right? Having iodine, so that's how you have to write iodine, I2. How can you balance the equation? The reactant side having how much oxygen in sulfuric acid? 4. So make the product side 4 water molecules. Next. 4 water molecules means the reactant side they're having 8 hydrogen and also 2 hydrogen having. So 10 water molecules. So make it reactant side 8 hydrogen iodide. So 8 plus 2, 10 over. Now how much iodine is there? 8 iodine means we can write 4I2. H2SO also balanced. Next about one of the important point. The reducing property of hydrogen iodide, it also can be explained by the using of its reaction with alcohols in the ethane. Alcohols in the ethane we have in our organic chemistry lesson, we can be discussed that time, okay? Next, nitric acid to nitrous acid, and also dinitrogen dioxide and aluminium. These are all previously we learned that one, except only alcohols into ethane. We have the organic chemistry, that time they have a lot of equation how to discuss. Next, about hydrogen chloride is unaffected by concentrated sulfuric acid, but affected by only strong oxidizing agent like MnO2, potassium permanganate, or potassium chloride. Next, one of the 2-mark question about one of the table form properties, about the properties and order. The reactivity of hydrogen. What is about the reactivity of hydrogen? It is decreases from fluorine to iodine. We previously discussed. Stability also same like that. Decreases from HF to HI. And the volatility of hydrides. That is about that. First is about that HCl. So we have to write the reverse order. HF, HI, HBr, ICl. This is less than. Am I right? You have to write. Thermal stability. HF, HI, HBr, ICl. You have to write greater than. Boiling point. ICl, HBr, HI less than. Acidic strength increases from HF to HI. Just one of the 2-mark question. Try to learn this question. One of the very important question. Interhalogen compounds. Interhalogen compounds. What is about the interhalogen compounds? That's each halogens, it may be a fluorine, maybe a chlorine, maybe an iodine or bromine. Each halogen combines with other halogen. This one of the halogen, maybe chlorine combines with another one fluorine. Bromine combines with other one fluorine. Iodine combines with other one fluorine. Maybe bromine with the chlorine. Iodine with the chlorine. Iodine with the bromine. These are all. One of the halogen combines with other halogen. Am I right? One halogen combines with other halogen. We get is a series of compounds, of a lot of compounds. A many form of series of compounds. That we are saying interhalogen compounds. Whenever we are going to write one interhalogen compounds, you have to write interhalogen compounds of a given compound. One of the compound A is less electronegative than B. First, you have to write which halogen have the high atomic number. That we have to write first. For example, it is only for an example. What is the atomic number of chlorine? 17. What is the atomic number of fluorine? 9. Am I right? So as we are comparing, which one have the high atomic number? Chlorine. So you have to write first chlorine, Cl. Next F. Okay. Which have the high atomic number? That you have to write first. Whereas we are comparing bromine and fluorine. Bromine atomic number 35. Fluorine 9. So which one you have to write first? Bromine. BREF. Okay. So such a way you have to learn practice. Okay. Here we have 4 types of interhalogen compounds. One is about that AB type, AB3 type, AB5 type, AB7 type. What are the different types? AB, AB3, AB5, AB7. Am I right? AB means they have a single atom. A also having single, B also having single. For example, CLF, BRF, IF, BRCL, ICL, IBR. These are all single atom, am I right? This we are saying AB. What about the AB3? A have a single atom, B have a 3 atom, am I right? CLF3, BRF3, IF3, ICL3. These are all what? AB3 type. What about the AB5 type? A means single atom, B means 5. Am I right? So, IF5, BRF5. Can you understand, my dear children? AB7 means IF7. These are some of the examples. One of the very important 2-mark question. Try to learn this one. Next about what are the properties of interhalogen compounds. Some of the properties. What are the properties of interhalogen compounds? I think that we have more than 5 or 6 points. So try to learn this one, okay? At least you have to learn 5 points. What are the properties of interhalogen compound? The first one. The central atom will be the larger one. The central atom will be the larger one. That is the first property. Second one, it can be formed only between 2 halogen, not more than 2 halogen. 2 halogen means we can be say, for example, CLF. How much halogen having? 2. CLF3. How much halogen having? 2. So, it can be formed only between 2 halogen, not more than 2 halogen. That's the point. Can you understand? Next one. Fluorine cannot act as a central metal, being the smallest one, because fluorine have the lowest atomic number as we are comparing other halogen. So, fluorine cannot act as the central metal atom. Okay? Fourth point. Due to the high electronegativity with the small size of the fluorine helps to the central atom to attain the high coordination number. Due to high electronegativity with the small size of the fluorine helps the central atom to attain high coordination number. We know that the small fluorine have the small size of an atom. Am I right? Fluorine is one of the small size in halogen family. Here, small size helps the central atom to attain, it have a high coordination number. Next about, they can undergo the auto-ionization process automatically. For example, we are taking ICL, iodine chlorine, undergoes auto-ionization, that is forming an ions. One is about the plus charge and another one is minus charge. ICL is converted into I plus plus, ICL2 minus. So how much chlorine there? 2 chlorine, so make it the reactant side 2. This is both forward and backward reaction. Same like that ICL3, forward and backward reaction. ICL2 plus, ICL4 minus, ICL2 plus, ICL4 minus, forward and backward reaction. So how much chlorine is there? 6 chlorine. So make it the reactant side, make it 2 into 3 is equal to 6. They are strong reducing agent. Next about the reaction with alkali. Reaction with alkali. When alkali is heated, the larger halogen forms oxyhalogen and the smaller forms halide. Here, BRF5. This BRF5 on heated with one of an alkali, maybe sodium hydroxide or potassium hydroxide. I am taking one of the alkali. Simply I am writing OH minus. That means it refers to an alkali. BRF3. Can you say this is a which type? BRF5. BRF5. Which type? AX5 type. That is AB5 type. BRF5 gives 5F minus, because you have fluorine 5F minus plus BrO3 minus bromate ions. Here, this is one of the larger halogen. The larger halogen forms oxyhalogen. That is BrO3 minus. Next one, ICl gives the presence of OH minus ions. We get Cl minus plus OI minus hypoiodate ion. BRF5. That is about that we can be say AB type. Okay, already we learned that interhalogen compounds can be classified into AB, AB3, AB5 and AB7 type. Here AB5 types, that is about that BRF5. On reacts with alkali, we get F minus and BrO3 minus. I am right here. Larger halogen and smaller halogen. Larger halogen means when we are comparing bromine and fluorine, the atomic number of bromine is 35 and the fluorine is 9. Which one is the larger? Bromine is the larger. So bromine forms oxyhalogen, that we are saying bromate ion. Bromine's form, that is a larger halogen, forms oxyhalogen, bromate ion. And the smaller halogen, that is a fluorine, atomic number is 9. It forms fluoride ion. Otherwise, we can be say halide ion. Am I right? That is about the first equation. Second equation, that is about that ICl. ICl means AB type. Here also having iodine and chlorine. Iodine is a larger halogen and Cl is the smaller halogen. Larger halogen iodine form OI minus, that is hypoiodate ion. Iodine, one of the larger halogen, forms hypoiodide ion, and the smaller halogen chlorine forms chloride ion, halide ion. That is about that, the equation. Next about, we learn about the structure of interhalogen compounds. What is about the structure? According to the structure, that is VSEPR theory, valence shell electron pair repulsion theory. According to this theory, the type AX, AX3, AX5 and AX7 type, what is the structure? AX has the linear shape, linear structure. AX3 is the T-shaped structure, T-shaped. AX5 is a square pyramidal structure. AX7 is the pentagonal bipyramidal structure. How can you explain this structure? And how can we explain the hybridization? And how can we explain the bond pairs and the lone pairs? First about the AX is AB type. Otherwise we can be say AX type. For example, I am giving some of the examples about that CLF, BR, EF, IF, BRCL, ICL, IBR. These are the AB type. Am I right? These are the examples. For example, I am taking the very good example is CLEF. CLEF. This is one of the molecule. CLEF. if I'm making one bond here, so this is the which shape? As per we can be say it is one of the linear shape. Am I right? How can we explain the linear shape? Suppose I am taking chlorine, 2 chlorine I am taking. All of you know that on halogen, what is the outermost shell containing electron in the halogen means? All of you know that on 7 electrons. So, one halogen having 7 electrons. 2 halogen means 7 into 2 is equal to 14 electrons. Am I right? 14 electrons. Out of these 14 electrons, I am making bond between 2 chlorine atom, bond between 2 chlorine atom. One bond means it need 2 electrons. So 14 minus 2 means we get remaining 12 electrons. So 12 electrons I am accommodating such a way like that. Chlorine, one side 2 electron, second 2 electrons, second, third 2 electrons. So out of this 6 electron over, am I right? Then remaining 6 more electron, I am filling like that. 2 electrons, 2 electrons, 2 electrons. Okay. Now 6 plus 6, 12, 12, and this bond having 2 electrons, the 14 electrons is over. So here we can be tell about that one chlorine atom. Suppose I am taking one of the chlorine atom. How much bond pair? Suppose I am taking this of this chlorine atom. How much bond pair and how much lone pair? So this is the bond pair. Am I right? This bond. This is we are saying the bond pair. How much bond pair having? One bond pair. So this chlorine atom, how much lone pair having? This is one lone pair of electron, other lone pair of electron, other lone pair of electron. So how much lone pair of electron? 2 lone pair of electron. Yes or no? 2 lone pair of electron. Sorry, 3 lone pair of electron. So 1 plus 3 is equal to how much? 4. All of you know that one. Hybridization 2 means sp, 3 means sp2, 4 means sp3, 5 means sp3d, 6 means sp3d2, and 7 means sp3d3. These are the numbers. Am I right? So number 4 means what is hybridization? sp3 hybridization. Next one is about that AX3 type. AX3 type I am taking here ClF3. So here having 4 halogens. So 4 halogen means one halogen atom having 7. So 7 3s are 7 4s are 28. Am I right? 28. 28 I am writing chlorine, fluorine, because here having 3 fluorine atom. 1 bond means 2 electron need. 2 bond means 4 electron. 3 bond means 6 electron need. Okay. I told that 28 is out of 28. 6. What's remaining? 22. I am accommodating the 22. First fluorine 1, 2, 3, 4, 5, 6. Next fluorine 7, 8, 9, 10, 11, 12. Next 13, 14, 15, 16, 17, 18. So remaining to 4 more. Am I right? So I am accommodating to chlorine, nearest to chlorine. So due to this here electron repulsion, we can be say like that. So the shape is some should be changed like that. We can be say like that, a T-shaped. Okay. We bend T shape. Okay, like that, a small bend like that. Okay, due to the electron repulsion, that is not in our textbook. So try to understand the concept. Okay, due to the electron repulsion is having a small change, angle will be changed. So it becomes just like T shape. Which shape? Now also we understand that one. This is which shape? T shape. So what is hybridization? We can find the hybridization. How much? For one I am taking 1 fluorine. Okay, 1 fluorine. We can be say for this molecule, this entire molecule, not 1 fluorine, the entire molecule, how much bond pair having here? 1, 2, 3. So 3 bond pair. Out of this 3 bond pair, alone we can be considered as a chlorine. So the central atom having chlorine. The central chlorine atom having how much lone pair of electron? 2 lone pair of electrons. So 3 bond pair and 2 lone pair. So if you are adding 3 plus 2, what is the number? 5. So 5 goes to which hybridization? sp3d hybridization. sp3d hybridization. Such a way you have to take return practice like that, AX5 and AX7. Okay. So okay. Anyhow, today assignment I am giving. What is today assignment means? Very, very important question. What are interhalogen compounds? Page number 89. What are interhalogen compound? And explain its types and what are the properties of interhalogen compounds. Okay. What are interhalogen compounds? Explain its types. That type means AB, AB3, AB5 and AB7. Properties of interhalogen compounds. Okay. Thank you all of you. Thank you. Have a nice day.